A very pleasant afternoon to you. How are you doing today?
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir. Doing good.
Nice, nice. I'm happy. I'm happy. How many of you attempted this question?
Yes, sir.
Yes, sir.
Very nice. I used that a while ago to demonstrate to me mathematical maturity. I'm sitting right here. Normally I give you 15 minutes. I'm sitting right here watching, and I say, you know what, let me put the question on without saying anything to see if these guys are going to just look at the question or they're going to actually attempt the question. So I'm very, 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 very proud of you, knowing that you have actually attempted the question. Now, because your teacher just write up this question, no, say teacher have to go do the question, all right? Because you never did it. And this is just a warm-up for what it is that you would have done before, to see if you actually remember what this thing is all about. So the coefficients are 1, 3, 3, 1. Then this now becomes 3 to the third power plus 3 to the second power. Remember, we always have a minus sign in between, right? I mean, sorry, a positive sign. We always have a positive sign in between. The minus sign will come out if there's a minus sign to come out. So don't change anything just yet. 3 to the first, negative 2x to the second, three to the 0, negative 2x raised to the third. Raised to the third power. Three threes, 9, 9 threes, 27, no?
Yes, sir.
And 3 squares are 9, and that is just going to be negative 2x. And 3 to the first is simply 3, and negative 2x squared is going to be 4x squared. 3 to the 0 is going to be 1, and negative 2x to the third, 4 is going to be negative 8x cubed. Twenty-seven times 2 is 54. Three threes 9, 4 nines 36. Can you agree with that, please?
Yes, sir.
Nice. Very nice. So that was a good warm-up. Now we're looking at the
Sir,
this one.
sir, I didn't get that.
Hmm?
I didn't get that.
What did you get?
27 162x plus 108x squared plus minus 8x squared cubed.
All right, so let's go through the coefficients. Do you agree that the coefficients are 1, 3, 3, 1?
Yes, sir, we
Yes,
get
sir.
everything until the answer.
So you have all of this too?
Yes, sir.
That means you don't know over multiply. Answer me. 3 nines. 3 times
27.
27 times 2.
Sir, but I would have said 3 times 2, 2. I just,
Okay, so let's go. Let's go. 3 times negative 2 is a negative 6.
yes,
Negative 6 times 9.
42.
If I take out
Negative 54.
if I take out $42,000 out of the account, you see, I can eat my curried lobster.
Sir, but I not think I said 3 nines, 27, then I say 3, 2 is negative 6, 27 times.
No. At a 1 year times a 1 year times a 1 year. No, man. Multiplication is commutative. You get, man. At this times, this is 27. 3 times 9 times negative 2x is negative 54x. Now 1 year times a 1 year times.
times the two of them by 3.
All right then.
Sir, I got that, but I did it the other way.
Which other way did it?
So, this is like descending powers of x.
Tani, you switch around this inside here.
Oh,
Did you?
not really, sir. I'm doing it in the same way. I'm just get the 8 first. The negative 8x first.
Okay. I'm wondering how you get the negative 8 first. If you do it this way, you have to get it in ascending powers of x.
Oh, sir, I never put the, sir, because I always say, like when we're doing x, you always put the
x first?
The power, yeah.
No.
So I never put the 3. I never put the 3 on this 3. I put it on the
negative 2x.
Yeah.
All right. Okay. All right. So let me just talk about that point again now. It's in this case, what is my a? It's 3.
3.
Yeah, man. So don't change up inside here. So not because, and it was deliberate incidentally. What was deliberate? Was me putting the x afterwards, because none of the other questions I had the x in the second part. I always have the x at the first. And none of the other questions I gave you included a negative sign. So I said, let me mix up with something. So you have to be very careful. Well, this one had a negative sign. So you have to be very careful, you know, with however they give you a question, keep it that way. So if x is in the B position, don't change it around, keep it that way. Because if it changes around, you know, this is not only negative, this is not 2x, you know, it would be a negative 2x plus 3. And a lot of students would leave off the negative sign here and just put the 2x up here and then the 3 over that side. So we don't want that to happen. So just leave it as it is. However they give it to you, it can be worked. Leave it as it is. All right. Any other question before we move? So I'm showing how a possible way for them to give it an answer. If they gave it 4 marks, it will be the distribution as you see it here. If they give it 5 marks, they'll give you 1 mark for correctly writing on the coefficients. or for correctly substituting into the formula. Okay, so tonight's class, not all of it, just a portion of tonight's class, I'm going to be teaching you the other method. And you need to have your calculators up because we are going to be looking at some calculations. We're going to be looking at some calculations. Now, we're going to be looking at some permutation, some factorial notations, and some combination. You will see these again when we move into module 2 on statistics, where it speaks about the combination and factorial, permutation and combination. And it speaks of permutation and combination. All right, so let's go. I need your undivided. I don't want anybody to blink. I need your undivided. So for the combination notation, NCR is going to be n factorial over n minus r factorial times r factorial. N factorial, which is this n up here, over n minus r factorial times r factorial. Sir, what is this factorial? The factorial notation is denoted an exclamation mark. The factorial notation is denoted an exclamation mark. It's denoted an exclamation mark. Now, n factorial is going to be n times n minus 1 times n minus 2 times n minus 3 times n minus 4 times n minus 5, etc., etc. So, for example, if I ask you to evaluate 5 factorial, 5 factorial is going to be 5 factorial is going to be 5 times 4 times 3 times 2 times 1. All right, so 5 factorial is going to be 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 30, times 3 is 60, and 60 times 2 is 120, and 120 times 1 is 120. So I want you to look on your calculator for me now. I want you to look on your calculator for me. And I want you to evaluate, find the factorial notation on the calculator. Look for the exclamation mark. It should be located to the top left-hand corner on your calculator if you have the good type one. Let me know when you find it.
Yes, sir.
Good. Then you're going to press 5 and then press that exclamation mark and press equal and tell me what you get.
120.
Magic. Magic.
Can go again, please?
It looks like I have the good one. Is there any other representation?
No. Oh,
It has a, it look if you see something with an X and an exclamation beside it. At like the bottom part of your calculator. Where you'd have to press shift to access it.
yeah, if it is on the raised key, you just press it. But if it is submerged, you have to press shift in order to access it. All right, so the question is asked for me to go again. If I ask you to evaluate 4 factorial, 4 factorial is going to simply be 4 times 3 times 2 times 1. See the general form here? N factorial is n. Then you subtract 1 from it, times n minus 1, times n minus 2, times n minus 3, times n minus 4, all the way down to k, which is your last term, which is going to be your 1. All right? So 5 factorial is going to be 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is 24. Are you okay with that now?
Yes, sir.
Come on. This
Yes,
is the easy part, you know. Not tell you straight up. This is the easy part. If you don't see it yet, it's fine. But I just tell you straight up. The part here are the easy part. Nothing to worry about. Easy part is. So now, so that's how we evaluate the factorial notation. All right. Now, I want you to get into the habit now of evaluating the combination notation. Remember, on paper, if they ask you to evaluate this, it's going to be n factorial over n minus r factorial times r factorial. Or you can simply look on a calculator to see if you see the NCR notation. You may see it as this n up here, c and a r there, or you may see the n, little n, then a big C, then a little r.
Yes, sir.
Good. So you're going to press so to evaluate 5 choose 3. Look at what happens here. To evaluate 5 choose 3, it's going to be 5 factorial over 5 minus 3 factorial times 3 factorial. See the formula here? The formula says it's n factorial over n minus r factorial times r factorial. So to evaluate 5 choose 3, it's going to be 5 factorial. The 1 here going to be up top, 5 factorial all over. This minus this, 5 minus 3 factorial, and then this alone, 3 factorial, which is here. But you know that 5 minus 3 is 2. So this is going to be 2 factorial times 3 factorial. Now, what is interesting is when you look at this 2 factorial and 3 factorial, if you add these factorials together, 2 factorial plus 3 factorial is 5 factorial. It's supposed to give you the sum up here. It's supposed to give you the sum up here. So when you do the combination, you can't have 5 factorial up here and then we have 4 factorial, 3 factorial. That don't make it, because 4 and 3 is 7. So that's an incorrect combination. So when you set up your stuff and you work it out and you break it down, the total that you have up here, the sum that you have up here, supposed to be broken up into such a way that when you add the denominator, You get back the numerator. Every single time it works like that. However, 5 factorial, as we would have worked up here, is 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. And 3 factorial is 3 times 2 times 1. If you look at it, 3 times 2 times 1 cancels with this 3 times 2 times 1. 2 times 1 is 2. 2 into this 4 goes 2 times, and that 2 times 5 gives me 10. So 5 through 3 is supposed to be equal to 10. Do me a favor. Look at your calculator now. You're going to press 5. Then you're going to press the NCR button. And then you press 3 and tell me if you get 10.
Yes, sir.
Yes, sir.
Very good. It's done. This part of it is finished. I can move it to the last part now. Do me a favor. All right, so that's the combination notation. That's how we work the combination. So if you look here, you see me have something that is called permutation. You see me talk about something that is called permutation. All right. Now let us look at the permutation. NPR. So of course you would have guessed it. The P is for permutation and the C is for combination. So if you're looking at the permutation, N choose NPR. It's going to be N factorial. Oh, sorry, the same thing like up here. So very good. Okay, I left off something right here. Please do forgive me. And it is going to be N minus R factorial. N minus R. Sorry, enough. You multiply by R factorial like you did down here. No. So that's the difference between the permutation and the combination. That's the difference between the permutation and the combination. I want you to be able to evaluate the permutation and the combination, because when you move into module 2, the statistics version, you will see why the R is not replaced. You'll see why the R is not replaced here. So it's me saying to you, there are 5 of you who work in a company. There are 5 of you who work in a company. And I'm the boss man. And I'm saying to you, how many ways can I choose 3 persons? In how many ways can I choose 3 persons to form a committee? In how many ways can I choose 3 persons to form a committee? And then you're going to say, sir, easy. 5 choose 3. You have 10 ways of doing it. 10 ways, sir. 10. Oh, or boss man. Boss man is only 10 ways. We can have 10 committee members. Okay. Look at what the permutation says. The permutation says N factorial over N minus R. So let's go. Here I did 5 choose 3. Now I'm doing 5 P3. It's going to be 5 factorial over 5 minus 3 factorial. Remember, we're not replacing the R. We're not replacing this 3. So when we evaluate, we're going to get 5 factorial over 2 factorial. And 5 factorial is going to be 5 times 4 times 3 times 2 times 1. And then the 2 factorial is 2 times 1. So my answer is going to be 60. Wow. So you're saying that there are 10 ways I can choose the committee of 5 with 3 different functions. And there you're going to say to me now, sir, that I have 60 ways of doing it in this case? Yes. There are 60 ways of doing it. So you can have a committee with 60 different people, with 60 different ways. So I don't understand what you're talking about. Okay. So I can have a committee with A, B, and C. All right. What did I say a while ago? We can have a committee with who?
A, B, and C.
Good. Now, if I have a committee with B, C, A, is that the same committee as the one before?
Sorry, yes.
No.
That they have the same members.
Have the same members, but the order is different. The order is different. No, it changes around things. The order is different. So think of it this way. And a matter of fact, this is not the topic that I'm teaching tonight. That is going to be in module 2, but I'm just touching on it now. Put it this way. So you have an executive. You have an executive. The executive consists of 5 people. But let me not even use the executive. Let me use the government of Jamaica. So the government of Jamaica has these 30 plus persons who are going up as members of parliament. If the prime minister is comfortable with all 30, it means that all 30 will go up again. And all 30 will be in the House of Representatives. Now, if all 30 of them didn't win their seats, and say A did not win a seat, so A can't be a member of parliament, A now has to be a senator. And if the senator was, and if A was a member of parliament and was the minister of health, for argument's sake, but A now loses his seat and cannot no longer be the minister of health, but now be information minister, are they still in the same government? Incidentally, that was a question.
Yes, sir.
What?
Yes, sir.
Do they have the same roles as before now?
No.
No. So the role has changed. So I have 3 committee members, A, B, and C. And I'm saying to you now that things change up. It's no longer A, B, and C because I can now form another committee with CBA. CBA is different from ABC. And BAC is different from ABC and CBA. So the arrangement of the members on the committee makes a difference. That's what the permutation is saying. And that's why you can have so many more when compared to the combination. The combination is saying to you now, say, here the plan. CBA are the same thing as ABC, are the same thing as BAC, is the same thing as ACB. It no matter how you arrange them are the same. All right. So you have to just make that distinction in your headspace. And when we get to statistics, we will explore a little bit more about that and start drawing some diagrams so you can have a greater appreciation of that. All right. But for the purposes of this, I just want you to be able to calculate what the permutation formula is versus the combination formula. The combination says n factorial over n minus r factorial, but the permutation one says only n factorial over n minus r factorial. You are not replacing the r factorials. And that's why for the permutation, you will end up with more when compared to the combination. Am I clear?
Yes, sir. Yes, sir.
All right. So, to be honest with you, we don't need to do no more examples of this because it is what it is. What I mean by that, you have the NCR button. Oh, incidentally, sorry, we never did that part. Put in your calculator now, 5, P3, and tell me if you get 60.
Yes, sir.
All right. There's nothing more to this. You know how the calculator evaluates the 60 now. You can actually do the calculation on paper and get the same 60. And if you want, you can do the calculation using a calculator to confirm your answer. So you know how to work the combination, how to calculate the combination. You know how to calculate the permutation, and you know what the factorial is. So this little piece here was pretty simple. You are CAPE students. Simple.
Sir?
Yes, please. Go ahead.
On the calculator, must see the button for the NCR.
Mm-hmm.
How can you get the NCR? You don't have a button, but it's down on the top of the NCR.
All right, so you have to go press shift in order to get that.
Where is shift?
Second function or inverse.
Okay, thank you, sir.
Yeah, and next time you're saying where's shift, make sure you enunciate properly because it sounded like something else a while ago.
Okay, sir.
Thank you, please. All right, but no, check it for me first, no, though, and tell me to see it. Waiting on you.
Yes, sir, I'm gonna get it.
Very good. Boy, I'm telling you, students. Today, I don't know where the crime is going in this country, you know. I don't know where the crime is going in this country. Senseless people are just losing their lives. Let me just pause and just say one and a half, please. It's when I end up on the road, me no want to say none of you have out on a phone on the ears, but wanna have no conversation. Wanna put the phone in on a back bottom. I mean, no one of the youth them in the class go like them are the baddest thing since sliced bread. Put up on a phone. When you go on the bus, don't let your phone ring out. Make your phone tremble. It is better for you to miss the call than for you to take out the phone and somebody push one knife in your side and then you go resist it and then cut your throat and run gone and leave you. And I'm being very serious about it. A cell phone can come back. If you have sensitive information on your phone and you fear that things going to be leaked, put a password on your phone. Put a password on your phone. Most of these cell phones don't come with a tracker, and some of them come with a shutdown button that you can just literally go down and just disable the phone so it has no use for anybody. Please, you know, we're not cheating upon the road. It's Christmas. Times are hard. People want a thing, and you know, just be careful. Be careful. Watch your surroundings. Watch your surroundings before you go. I know some of you ladies, and forgive me, I'm not being typical, but forgive me. Some of you ladies are not observant of your surroundings, and some of you ladies, or ladies on a whole, are seen as an easy prey because the man they may put on, or the schoolboy they may put on a little challenge for the little gunman then. So ladies, please, when you're up on the road, we see people are walking on the road and having cell phone cut off of them ears and having long conversation. Ha ha he he. And the other thing I don't want you to do is up on the road or walk and have your headset and you have your long sitting wire a dangle. Then no, say you have phone on you. And even if you have an earpiece, somebody walk up and down with the earpiece and like you're hot. Leave that phone in your yard. Please, students, I don't know what I will do if I know say one of my students are hurt. Please don't want to play macho. And if them come to you, if you take with the phone, give it to them and ask them if they want an exercise book or a pen or a pencil with it. Don't bother put up no resistance. A cell phone can be bought. Your life cannot be bought. All right. I'm warning you. I'm begging you. I am beseeching. You leave out. You leave out. Before you leave out, you put the phone on ticklish. When was it? Last year, it's coming up to 1 year now. Last year, one of my past students was leaving out of our house in Portmore, the 5:30 bells to go to work. And she have a phone. Mark you, I had a similar phone to that at that time last year. One cheap phone. And right in front of our yard gate, one gunshot just for the phone, the 5:30 bells in front of her mother. And she's gone for a cellular phone. For a cellular phone. And then he got into the cell phone and started calling people out there and start threatening and start all that. Please, guys, I beg of you, it's Christmas. It's rough. Crime is up. Be very careful. Finally, before you fund on one taxi, we go in there. If the taxi stop on the foot, and you see just the male driver inside there, as a female, do not go in there. And if you see two men in there, and you look like one of them totally disengaged, and you look like him a Christian, for want of a better term, no go in there. Don't go in there. It is better for you to stand up and wait on one of the JUTC buses. Please. Okay. I just have to say that. Forgive me. Let's move on. All right. So before I move on though, are there any questions read the combination, the permutation, and the factorial notations?
No, sir.
No, sir.
All right, because the truth is, if I were to be very honest with you, the truth is, I want to know difficult. And this is not even anything to gloat over, you know why? Because I don't think I'm going to get a question on this in the exam for calculate the permutation for that. You can use this calculation into the other topic, which is the alternative now to the Pascals. Right? So the triangle looking thing coming out again. Yes, sir. Me like Pascal, sir. And look here. After that summary, I'm going to delete this. After that summary, I'm into my AP, right? So this is really not, this part is not difficult. It's not 6:21. In another 15, 20 minutes, I should be finished with this one and moving to the other topic. I'll give you 1 or 2 questions to do just to build your confidence. So combination, right? So we'll finish with the permutation and combination. So we're not using the permutation this time now. We're just going to be using the combination. So I want to spend a little time with you on this. For those of you who are multitasking at this point in time, I'm going to ask that you stop multitasking. Stop the multitasking now and just give me about 5 minutes out of your time. I want you to watch this. If you blink, you're going to miss something. I don't want you to blink. Watch me. A plus B to the n. Does this look familiar?
Yes, sir.
It does. So this is your binomial. Remember, we're talking about binomial expansion, you know. So this is your binomial with your 2 terms. It's a binomial with your 2 terms. The binomial with your 2 terms. Oh, I see it now, sir. The A and the B, sir, raised to a power. Now, depending on the power, and remember, we are only concerned with powers up to the 3rd one. We're not concerned with anything greater than 3. So for you, we can say that n can either be 1, 2, or 3. And of course, they're not giving a question with n equal 1. Because if them give a question with n equal 1, that is a no-brainer. That it can't get a question. So the most we give is a question raised to the 2nd power and a question raised to the 3rd power. And guess what? Me not think I'm going to give a question raised to the 2nd power. That is just way too easy. That's a waste of question. How much mark am I going to give you? 2 marks? No more than 3? No, man. We're going to give a question with a 3rd power for either 4 marks or 5 marks. All right? So watch me. A plus B raised to the n power is exactly what it is that we would have done in doing our Pascal's triangle. As I said to you, this is an alternative method that I'm teaching you. You choose which method you prefer. It don't mean nothing to me. Don't mean nothing to me. Whichever one you want to use it. Watch this. I'm using my combination, and I'm just going to point out the sequence of stuff first. So watch. No blinking. This is the highest power n, so it's going to be n choose 0. Then I got n choose 1. Then I got n choose 2. Then I got n choose 3. And then I go along until I reach n choose n. Sir, explain n choose n. What if this were 5? This would be 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. Can I have 5 choose 6? No. I can't have 5 choose 6, right? So when I reach the same number up top and the same number on the bottom, it means that I finished where I'm supposed to reach. So let's go again. If this were 3, it will be n choose 0, n choose 1, n choose 2, sorry, 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. The number up here, so, can be smaller than the number down here, so. But the number up here, so, can be equal to the number down here, so. But the one down here, so, can grow past the one up here, so. So I can't have 5 choose 6. I can't have 3 choose 4. All right? The one up here is up on top, big. It can be equal to this, but this at no point in time can be bigger than this. But of course, this can be bigger than that. Okay, so I'll show you what the C's look like. Let us look at the A term. Remember, the A are the first one and the B are the second one. It does not matter if this is a whole number and this one is a variable in X. And incidentally, they don't have to give the question with a variable in X. Them can answer with a variable in P, Q, R, S, T. Them can give a 1 plus 2S raised to the second power. Expand that. It does not have to be in X. All right? So watch me now. A to the N, B to the 0. A to the N minus 1, B to the first. A to the N minus 2, B to the second. A to the N minus 3, B to the third. Does this look familiar to you?
Yes, sir.
Yeah, man. Because when A descends, B
Ascend.
ascends. Very good. Sir told you this, you know, and that's why Sir was talky the last class, because I knew I was going to come back to this one. So this part is not unfamiliar to you guys. This A to the N, see here, the A here starts off with a bigger number. Remember what I said a while ago? That, sir, you know, because obviously you do use the X, sir, I do just raise the negative 2X to the first power. So that's why I need to get my one in descending powers of X. Right? But no, what I want is that the A is always going to go up to the highest term, the highest power, and then reduce it as we go along. So A is going to go up to N and then B to 0, because you see all the other rules that Sir pointed out to you still remains. The 1 plus the 1 is supposed to be equal to N. Watch this. N minus 1 plus 1 are N. N minus 2 plus 2 are N. N minus 3 plus 3 are N. N minus N plus N are N. So the power is supposed to always be the same when you add them, just like Pascal's. Just like Pascal's. I showed you this in Pascal's. It remains the same way using a combination notation. All right? So A is when you lose 1, B picks it up. See here, N minus 1, B pick up the 1. And I'm going to lose 1 more, N minus 2, and B pick it up to turn squared. N minus 3, and B pick it up. The final thing I'm going to show you, because I did ask for 5 minutes. You see that number down here, sir? Supposed to be equal to the number up here, sir. The 1 here to the 1 up top. The 2 here, 2 up top. The 3 here, the 3 up top. The N here, N up top. So you can't have 0 here, so. And then you have N here, so. That will make it. Mathematics is a studying of patterns. So the pattern in math must be carried forward through everything. But sir, we get the same answer. I don't care. Your pattern is incorrect. It means that you're not going to get the mark for the incorrect patterns up there. Put it this way. As I often say to my students, if you look at an evergreen tree in Jamaica, and the leaves of an evergreen tree is peculiar, and you go and find an evergreen tree in America, hello, that peculiarity is going to be the same, because it comes from the same family. So what I'm saying to you is, follow the sequence. Mathematics is a study of pattern. Follow the sequence. Let me go through the sequence one more time. You're now using a combination. N choose 0, then N choose 1, then N choose 2, then N choose 3, and if this were 4, that would be N choose 4. All right? But remember, I said to you that if we're in the 4th power, we're going to end up with 5 terms. If we're in the 4th power, we're going to end up to 5 terms. If we end up to 4th power, we're going to end up with 1 more term. Anybody remember me saying that? Oh, I wish when I'm teaching that my students will respond to me. This is being raised to what power, guys?
3rd.
Third.
The third
How,
power.
how many terms do I have?
4.
4.
4.
1, 3, 3, 1. See here, 1 term, 2, 3, 4 terms. All right. So you end up with 1 more term. So the reason here you end up with 1 more term, because it's starting off with n choose 0. That's why you end up with an additional term. You're not starting off like we do in math, counting numbers are 1, 2, 3, all the way up. We're starting off with n choose 0. So this accounts for the extra term. All right. Okay. So you know how to use a calculator because I just showed you. I have an activity there. 1 choose 0 is 1. 1 choose 1 is 1. 2 choose 0 is 1. 2 choose 1 is 2. 2 choose 2 is 1. 3 choose 0 is 1. 3 choose 1 is 3. 3 choose 2 is 3. And 3 choose 3 is 1. But hold on, sir. There's something you look familiar. 1, 1, 1. 1, 2, 1. 1, 3, 3, 1. Oh. Is there anyone in the class seeing what I am seeing?
Yes, sir.
Yes, sir.
What are you seeing?
The Pascal.
Pascal
Pascal
triangle.
triangle.
Very good. So the combinations here are giving you the coefficients. So what's the point I'm making? The Pascals is an easier method than the combination notation, but the combination notation has a particular application to it where Pascals fall down. You see, just like indices and logarithms, I can use indices every time. Sorry, I can use logarithms every time. But indices can only be used when I can write them in the same base. Talk truth.
Yes, sir.
But if I can't write it in the same base and I use logarithms, and if I can still write it in the same base and I use logarithms, I get the same answer. So if I use, so when I'm talking about logarithms, I can use, it works every time. Indices is very useful, but indices only sometime-ish. Only when, you know, say your friend drive pretty car, you can friend the person. But if the person that want to walk foot, you don't want to friend with that person there. Logarithm say, I don't care who you are. I can work it. Indices says, I'm sorry, I commit a limitation. What is the limitation? The limitation says I can only solve an equation when both of them can be written in the same base. Hear me out now. Pascals versus combination notation. Pascals is saying, I'm sorry, I commit a limitation. I can expand binomially, you know, different expressions. But if you ask me to tell you what the 5th term in an expansion is going to be, I will have to first write out the expansion for everything and then count out the 5th one. The combination notation, no, we can just write down the 5th term without writing out everything. Only that one them I want. So we now write down nothing else. All right? So I'm going to show you the main difference between the combination notation and the Pascal versus the Pascals. All right. So now you recognize that this one here is the same as for your Pascal. It gives you the same coefficients: 1, 2, 1, 1, 3, 3, 1. Remember, we're not doing anything higher than that. But of course, the other one would have been 1, 4, 6, 4, 1. And we would have seen the 1, 4, 6, 4, 1 from up top, right here. All right. So now let us work one of these questions. Before I do that, though, are there any questions?
No,
No,
sir.
sir.
No, sir.
All right, cool. All right, and my asking you the question so many times is just to make sure that you guys are awake, and thank you for keeping me awake. All right, I get the energy when students are also energized. All right, so all right, so I have that one. I did this one. All right, so let me do this one with you, and then I ask you to do one on your own. So you saw what the syllabus says. The syllabus says I can just tell you what the coefficients are and you work the question, or teaching the Pascals is enough. And you say I can also use other methods. But they are saying that I can just use Pascals, but I'm showing you another method so that at least you're versed. Let's go. Use a combination notation to evaluate. Oh, I see the point now, sir. So just like how the question says, expand the following using Pascal's triangle, they told you what method they want you to use. So if you use a method other than what they indicated, you can get it wrong. However, for the case of the CAPE integrated math, they won't be specific with a method. So they won't say using Pascal's or using a combination notation. You know why? Because the syllabus says you can use any one of the two. So all the questions we just said to you is expand, like how I give it a warm-up today. That's what the question just going to say to you, expand. No, when you tell you to expand, any method you want to use, you can use it. If you want to use a combination notation, for your business. If you want to use Pascal's, still for your business. All right? So they won't tell you specifically to use a method. All right? I am doing it because I want to make sure that you use the method that I'm asking just to see that you're understanding that method. So let's go. Work with me. So this is what I'm expanding. This is what I'm expanding. 2x plus 3 raised to the third power. It says in ascending powers of x, but remember, we now look on this until we finish expansion. When we finish the expansion, now we can put it in ascending powers of x if it is not already in ascending powers of x. So let's go. The number up here, I want 3. So we're going to start with 3, 2, 0. See this? So 3, 2, 0. Oh, yes, sir. I remember say start with 0. And that's what I count for the extra term. Because in 3, that means we have 4 terms, sir. I got you. So this is 3, 2, 0. All right? This here is when it gives you your coefficient. And then from Pascal's, and the same thing we're doing, this is going to be 2x raised to the third power. See it right here, sir. 2x raised to the third power. And the b is going to be raised to the 0 power. So it's going to be 3 to the 0 power. See this, sir? No change. The only thing that has changed is you using a combination right here, sir. Okay, sir, I got you. Then I'm going to put plus. Then, sir, why not minus? Remember, even if the question had a minus sign inside here, so you are still going to have your plus sign separating here. And then when you work it out, the minus signs will come out. All right? So if this is 3, 2, 0, the next one then going to be 3, 2, 1. See it yourself? 3, 2, 1. And if this is 2x to the third, that means the other one going to be 2x to the second. See it yourself? 2x to the second. And if it's 3 to the 0, that means the other one's supposed to be 3 to the first. 3 to the first. Sir, I get you. Because 2 plus 1 gives me 3, right, sir? Yeah. And the last one right here, so and the one is supposed to be the same. Something, see it? 0 and 0, 1 and 1, the 2 here and the 2 up here, so a 3 here and a 3 up here, so sir, I'm catching it. And then if I have 3 choose 1 here, so that means the next one's supposed to be 3 choose 2. See it, sir? 3 choose 2. And if this is 2x to the second, that means this is 2x to the first. And if this is 2x to the first, that means this one has to be second. Why, sir? Because 1 plus 2 must give it 3, and a number here, so. And a number here, so must be the same. And if this is 3 to the first, that means this is 3 to the second. So there's 3 ways to look at it to know, say, it's supposed to be to the second power. 3 different ways. All right? And then now, we have 3 choose 2, then we got 3 choose 3. Sir, but he said to us that whenever the n and the r are equal, that's when we're going to stop. Absolutely. You notice I don't have another term? Because if I have another term, I'm going to go 3 choose 4, and that don't exist. That don't exist. And if this is 2x to the 0 to the 1, that means this is 2x to the 0. Remember the number here and the number here are supposed to be the same, and the combination finishes right here. Easy, easy. You're going to know that 3 choose 0 is 1, 3 choose 1 is 3, 3 choose 2 is 3, 3 choose 3 is 1. Yes, and that's why we get this palindrome I was telling you about, because 3 choose 1 and 3 choose 2 are the same numbers. Let me show you up here why they are the same numbers. Look here. So 5 choose 3 is 10, and 5 choose 2 is also 10. Check for me. Check for me the value of 5 choose 2 and tell me what you get.
10.
All right.
10.
The same thing. The same number is supposed to get. You know why? Multiplication is commutative. Multiplication is commutative. What do you mean by that, sir? 2 times 1 is the same thing as 1 times 2. Hold on. Christmas has come. The place get dark very easily and quickly. Let me just get the light in the house. Oh, don't want it too bright. All right. So I'm showing us, I'm doing something here now. 5 choose minus 2. And this is going to be 2. This is going to be 3. This is going to be watch me. So we already established this to be 5 choose 3 is going to be 10. Watch 5 choose 2 now. 5 choose 2 is the same thing up here. 5 factorial. 5 minus 2 factorial times 2 factorial. This one over here, we had 2 factorial times 3 factorial, but this one we have 3 factorial times 2 factorial. Multiplication is commutative. 2 times 3 is the same thing as 3 times 2. So no matter what it is, you're going to end up with the same 10. So this is what explains the palindrome. This explains the palindrome that we have. All right. So that's how we get these two middle terms to be the same thing. All right. Now, watch me. Note 2x raised to the third power is 2x times 2x times 2x. So this is going to give us 8x cubed. So this one here, this 3 choose 0 is 1. So I'm going to replace it. So I'm replacing these combinations now with the Pascal's number, which is just technically what it is that you're doing in any event. And then now the question continues as we normally work it in Pascal's. 2x to the third is going to be 8x cubed times 1. This is 2x squared, which is going to be 4x squared. See it right here, so. And 3 to the first power is 3. 2x to the first is the same thing as 2x. And 3 squares is 9. And 2x to the 0 is 1. And 3 cubes is 27. And you're working out all of this. 8x cubed times 1 times 1, 8x cubed. 3 times 4 is 12 times 3 is 36, x squares. 3 times 2 is 6 times 9 is 54, x. And 1 times 27 is 27. I want to please note that the answer here is written in descending powers of x. See here? X cubed, x squared, x to the 0. In the descending powers of x. However, the question asks for ascending powers of x. All we need to do is to simply reverse the order to give us 27 plus 54x plus 36x squared plus 8x cubed. Voila. That's your answer. It is pretty much similar to what we would have done with Pascal's. The only thing that we're introducing is also combination, and you now recognize that the combination really still give you the coefficients from Pascal's. Really still gives you the coefficient from Pascal's. Are there any questions?
No,
Yes,
sir.
sir, how you calculate like the 3 choose 1 and on the calculator?
You just joining class?
So I reached late, like 30 minutes late.
You reached like 30 minutes ago?
No, 30 minutes late, sir.
Okay.
Like 6 after 6.
You see, you have to come in early now. I'm going to explain to you where you have to come in early, and it goes for everybody else, other from John Mark. Matter of
Yes,
fact,
sir.
John Mark, hold on there. No, hold on there, John Mark. You never come class last week? I mean, on Friday?
Oh, no, sir, I missed class.
Hey, Bridget, me ever fight, you know? You can't miss class in the
Right,
John Mark
sir.
because,
Yeah,
yeah,
we can't fight.
man, of course. And it's a good fight. We'll go police station, go fight. A good fight. This, I will go to the pastor in the church and fight. This is one good fight. All right. This does not necessarily apply to you, John Mark. And I remember that you weren't in class because I was marking the register that I need to do tonight, and I was calling, and you weren't answering. I think Powers was the only one. Powers and La Forest were the only guys present on Friday. No, let me just say something. And this, as I said before, is not targeted at you, John Mark. But for the rest of you, all of you students, you see, when you miss my class, best believe that sir is going to send out the recordings, right? If you notice the recording that I sent out over the weekend just indicated Educasoft navigation, because we never did any teaching at all. I was only navigating you how to use Educasoft before we went into our test. On Friday. But I'm going to say to you, if you miss one class, trust me, you're going to miss enough, because of 3 hours. And this teacher, when he comes to class, you know what I did all day today? I did the same thing on Friday for you. All day today, I got up and I started making notes. And I make notes and I'm tired, and I said, okay, fine. And I'm making some more notes and I'm tired, and I said, Jesus, I'm tired. And then I said to myself, okay, don't try kill making the notes in one day. Do little, day by day, and you will get there at some point. I'm saying this to say to you that I am doing the preparations for you. So when I come to class, I have the material to teach for the 3 hours. Matter of fact, if you give me 5 hours to teach, we can find the material to teach for 5 hours. So I want you guys try as best. I know things happen. Don't get me wrong. But I'm going to ask you, if you miss a class, you need to watch the recording, touch base with the classmate, so we can do the stuff. All right? Okay, John Mark, look on your calculator. You're going to see NCR and NPR for me. It normally come around the 5 button or the 7 button or the 9 button. Hello.
Yes, I'm looking. I don't see that.
Calculator not good. All right, hold on 1 minute, please, John Mark. All right, I'm gonna talk to John Mark about how to find the stuff. Just catch him up a little bit. What I want you to do for me, guys, is I'm leaving this workout right here. So see, I have a new question on here: 2 minus 3x to the 3rd power in ascending powers of x. I want you to use the combination method to see if you get the answer. Using this method, because I'm teaching you both methods, as I told you, use this method to do this question, and just ignore John Mark and myself. Now we're going to have a conversation about how to get this stuff. All right, so the rest of you go and work for me, please. Okay, John Mark. What brand calculator are you using?
Sir, the Texas instrument.
Oh Lord, that's why I'm not seeing it. Where is my Texas calculator? I need to work my Texas calculator so I can help you. I'm a Casio guy, so I know the Casio calculators like inside out.
Not on the Texas.
It's not on the Texas?
No,
Oh,
sir. I have to go for my Casio.
sorry, John Mark. So you have to go use the notation. And thanks for that, thanks for that, because guess what? some calculators. I remember when I was in school, I had my first calculator was a Texas Instrument, and I remember when I was doing admats in high school, they never had the combination something on it. And anytime we go into the exam and get a question with a combination, I have to use a factorial notation and calculate it. So when I take 1 minute to do the question, my classmate them a bit in 2 seconds because I never had it. So I would agree with you. Maybe the settings are. I'm gonna find my text first and see if I can do something. Anyhow, so John Mark, what you need to do is 3 choose 1 is going to be 3 factorial over 3 minus 1 factorial times 1 factorial. Sorry guys, I'm moving this 1 minute. Quickly, John Mark. Look here. So 5 choose 3 is going to be equals to 5 factorial. See the formula here? NCR is n factorial over n minus r factorial times r factorial. N minus r is this factorial times r factorial. So 5 choose 3 is going to be 5 factorial over 5 minus 3 factorial, the 1 year minus the 1 year, and then the 1 year. So the 5 factorial is going to be up top. Then when you reach at the bottom, you're going to say 5 minus 3 factorial. Then you're going to have 3 factorial right here. So, right? And when you subtract 5 minus 3, you can get 2. Now, what I was suggesting to the students in class is that when you're using a combination notation, when you're using a factorial here to evaluate it, when you the sum of these two numbers in the denominator is supposed to be equal to the number up in the numerator here. So 2 plus 3 is supposed to be equal to this 5. All right? And 5 factorial, the factorial means that it's going to be 5 times 4 times 3 times 2 times 1. And the 2 factorial is going to be 2 times 1. And the 3 factorial is 3 times 2 times 1. And this 3 times 2 times 1 cancels with this 3 times 2 times 1. 2 times 1 is 2. 2 into 4 goes 2 times. And 2 times 5 is 10. All right? So that's how we work it out. It's going to be a little bit laborious for you because the calculator can't do it. But that's how we work it.
Yes, sir. Thanks.
Bless your heart. I give you 3 more minutes. Always stay. We get it?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Nice. Very nice. My question to you, is there anyone in the class that is still working on it?
Yes, sir, I'm still working on it.
Okay, take your time, John Man. And I appreciate your honesty. So I am learning while you're working. Just listen to me, please. I'm learning from my one-on-one contact now with students that you're not all 100% honest with me when I ask the questions in class. In our one-on-one conversations, the truth is coming out that you are not understanding. I'm going to encourage you that if you really not understanding in class, say something. I am more than willing, more than happy to explain. Look at what I have on the screen for argument's sake. All of that is not because I don't have anything else to do. Just sit down and type up all of them. Something here for you is, it takes a lot of time. I could come to class and I could take up my whiteboard and I could just write, make up questions as I go along and just write. Incidentally, I may end up having to do that pretty soon too, right? Because it is taking a bit longer for me to get some of the stuff done up. So there will come a point where I have to go to the whiteboard and start writing. But if you're not understanding, please, will you talk now? All right, I'll give you another 2 or 3 minutes, John Mark. I really want you guys to get this so I can move. Okay. John Mark, how far you reach, Papa? Finish?
Yes, I'm finished.
All right, so I'm going to project the answer and look at it. Be honest with yourself. Be honest, very honest with yourself. And let me know if you got those. Everybody got that?
Yes, sir.
Yes, sir.
Very
Yes,
nice.
sir.
Very nice.
No,
What a,
sir.
okay, because I was about to say, everybody now tell me the truth. All right. So what did you do? Uh-oh. What didn't you get?
So I didn't get it, but I got the answer.
I
But
couldn't figure it out. Me feel like me did I write but the same things them over and over and over. If you understand what I'm saying.
Okay. And that's fine.
sir, we never get it either.
All right. No problem.
Sir,
Mm-hmm.
I got it wrong, but that's the reason why I got it wrong. I did not remember to put the 1 3 3 1 for the
Mm-hmm.
combination.
Okay. Okay. Got you. Got you. All right. No
Yes,
problem.
sir. Same.
So, sir,
Okay.
even if it's a negative raised to the power 0, it's just 1.
Always.
Okay.
Always.
Never mind, you see I'm gonna go wrong.
No problem, Javier. All right. Let me just say it and just get it out of the way. When just learning is something, so if you don't catch this one question, when you don't think there's something wrong with them. Understand? Because I'm hearing some of it, the tone in the voice. Sir, I mean, I get it. I mean, I do. No, I don't want to hear that. It's the first time you've seen the question, or I assume. Just chillax. That's why I'm here. Let's go to the question. So we have 2 minus 3x raised to the third power. And as I said before, we're not even worrying about this ascending powers of x and descending power of x. We're not worried about that part. All right. We're just interested in working out this piece first. We'll look about the other pieces later. All right. Now, the power here is 3. So it's going to be 3 2 0. And then when we write 3 2 0, it's going to be 2 raised to the third power. See here. And the b is going to be to the 0 power. So how you know that? Remember from Pascal's? When one descends, the other one ascends. The a must descend first before the b can ascend. The a must descend first before the b can ascend. So this is going to be 2 to the third power, right? So negative 3 is going to be raised to the 0 power. So how you know? The 0 down here, so is going to be connected with a 0 up here, so. And the 0 up here, so when added to this number here, so suppose you give me this number right here, so. All right. Then, if this is 3 choose 0, the other one must be 3 choose 1. Go ahead. Somebody wanted to ask a question. Go ahead. Hello. So that means this must be 3 choose 1. And if this is 2 to the third, that means the other one is 2 to the second. And if this is negative 3x to the 0, the other one must be negative 3x to the first. Then plus, if this is 3 choose 1, the other one must be 3 choose 2. If this is 2 squares, the other one must be 2 to the first. If this is negative 3x to the first, the other one must be negative 3x to the second. If this is 3 choose 2, the other one must be 3 choose 3. And the mere fact that the top one number and the bottom number are the same, it means that after the last time I'm going to use this up here, so we do have another one after this. And if it's 2 to the first, that means the other one has to be 2 to the 0. And if this is negative 3x to the second, the other one must be negative 3x to the 0, to the third. So once you work on the first one and get the first one right, spend the time and work on the first one and get the first one right. When you get the first one right, then the other one, this, you're going to use this to give with this. You're going to use this to give with this. And we're going to use this to give with this. And when you get all of this, all you need to do is just evaluate. 3 2 0 is 1. 2 cubes are 8. Anything raised to the power 0 is 1. That one that's done. 3 choose 1 is 3. 2 squares is 4. Negative 3x to the first power is negative 3x. 3 choose 2 is 3. 2 to the first is 2. Negative 3x all squares is positive 9x squared. See, track yourself? Positive 9x squared. And then 3 choose 3 is going to be 1. 2 to the 0 are 1. And negative 3x raised to the third power is going to be negative 27x cubed. And finally, 1 times 8 is 8 times 1 is 8. 3 times 4 is 12 times a negative 3 is going to be negative 36. And 2 times 3 is 6 times 9 is 54, 54x squared. And 1 times 1 is 1 times negative 27x cubed is negative 27x cubed. Natalia, talk to the teacher now. Are you seeing that a little clearer now, honey bunches?
Yes, sir.
All right, hold. Please do not get frustrated on me, all right? You have another example there. Use a combination to evaluate this one for me. I'm giving you 5 minutes. John Mark, where you stay?
Sir, I'm good, sir. I'm good.
All right, nice pop up. See, I have another one. La Forest is in class tonight. Matthew?
Yes, sir. I'm there.
You all right?
Yes, sir.
Nice. Let me see now. All right, cool. Shariko, you all right tonight, mommy?
Yes, sir.
Feeling better?
Yes, sir.
Nice. Tariq, you all right?
Yes, sir.
Good, good. And the Tatianas are okay?
Yes, sir.
Good. Where is... Okay. All right, continue working. I'll give you a couple of minutes to do this one, please. Thank you. Obviously.
Finish, sir.
Finish, sir.
Sir.
Finish.
Tell me if you agree.
Finish, sir.
Yes, sir.
Yes,
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 sir.
sir.
Yes, sir.
Very nice.
yes, sir.
Okay, good. Is there somebody in the class that did not get what I got?
Sir, one of my signs are in.
All right. Can you look to see why you understand why it is incorrect now? Hmm. You see why you saying incorrect now, pumpkin?
Oh, yes, sir. Yes, sir.
Okay, cool. All right. That's it. I have other questions here, but this one may not be for you, so I'm not going to do that one.
Sir, me can ask a question, please?
Absolutely.
Sir, how you know when it is not a descending power X?
Watch it.
And
Watch it. X to the third, then X to the second, then X to the first, then X to the zero. Is it a go down? Talk truth. Talk to me now.
sir, me literally left off the powers. I never know which the
Me say, oh look how me go fall out. So if you have only 27 minus 54 plus 36 minus 8, it's wrong. You know? It's wrong. So you must have 27x cubed minus 54x squared plus 36x minus 8. Yeah, man. What do you recognize with this question and the question that we did before?
Sir, repeat, please.
What do you recognize with this question and the one we did before?
the answers are the same but different powers. Or them one of reverse or whatever it is.
Yeah, different sign.
One is in different, it's in different order, as in ascending and descending.
All right, and the signs are also
And the sign
different.
name different.
And the signs are different. All right. Now, oh Jesus. Tanir, come pumpkin, unmute and come talk to teacher.
Yes, sir.
All right. So you remember Tantan when you were oh no, yeah. You stay muted, Tantan. You stay muted, honey, but your background nice. All right, Tantan. I really hope you poke better. I'm not even hoping that because I know you are one who speak to me consistently, so I know you're following. So Tantan, this is me troubling you in class now. So it's like I preempt you asking that question in class earlier. You remember you're saying that, oh, sir, they put this one up to the third power. See it here, sir? That one up to the third power. But you told me that they got the same answer. But you see, somebody know when them put the 3x to the third power, them not going to carry this 3x as a negative 3x. Them just going to put this 3 in front of this and the 2 behind it. So you notice this 3x here is a negative 3x, but right here says a positive 3x. And this 2 is a positive 2, but right here says a negative 2. So it makes a difference. It's not just that it reverses, from ascending to descending. You hear what Matthew say? So the sign them change too. Because the one you positive 27 up here, so negative 27, so the sign them change. So you have to be careful that you don't go and rearrange the positions of A and B. Please. Oi. Parentesses. Paren. Promote. All right. So please don't go about rearranging inside the parentheses. Please, I beg of you. You know, when you get them easy question for 4 and 5 marks, you can't lose a mark out of it. Can't lose a mark because you may book up on a question that you don't know how to do, and you may have to sacrifice those 5 marks. So you don't want to end up losing 7 marks or 8 marks. Just lose the 5 marks. All right. I'm going to let this one stay. This is a special application to the combination notation. All right, but I'm going to let it stay. Some other time we can talk about this. Right, I won't delete it from the stuff that I've sent off to you, but not now. All right. So this is now 7:30. I have an hour. Let me give you a little screen break. I'm going to give you a 10-minute screen break because I want to clear your mind to come and start in something new. I'm going to start and finish my arithmetic progression, and then now we can do a whole heap of questions thereafter. I'm going to start and finish the procedure, the introduction and everything to the arithmetic progression. So I'm going to give you a 10-minute screen break, between a 5 and 10-minute screen break. Go and walk. I mean, even if you have to walk around in your room or you stand up and you stretch, I don't want you to be sitting for too long. And just take a break from looking at the screen for such a long time. The 3-hour class. So take a 5-minute screen break. Use the bathroom in the process, put on some tea and whatever it is, and then we'll come back. All right?
That's
All right, guys, are we back?
Yes, sir.
Yes, sir.
Nice. So, having gone through binomial expansion, and we are, hold on, hold on. All right. So having gotten our little break and having completed now the binomial expansion, we are now really moving on to the arithmetic progression. Wow, arithmetic progression is cool, really cool, a really nice area. So there are several things. There are several things that we need to learn. Some definitions to the arithmetic progression. You know, sometimes anytime we talk about AP, it means arithmetic progression. And when I talk about GP, it's not general penitentiary I'm talking about. I'm referring to geometric progression, right? So when I speak about arithmetic progression and geometric progression, these are things that classify themselves on the sequence and series. On the sequence and series. All right? And then we now need to look at those that are arithmetic, and then a little later on, we'll look at those that are geometric in nature. So for the arithmetic progression, we're going to be speaking about our first term as and denoted A. So once we're talking about AP, arithmetic progression, and we speak about A, we know we're talking about our first term. We know we're talking about our first term. And when we talk about D, we are talking about the common difference. When we talk about D, we're talking about the common difference. Okay, thanks, Tanine. I'm just seeing this message. When I talk about D, I'm talking about the common difference. When I talk about L, I'm talking about the last term. And when I speak about N, I'm speaking about the number of terms. And then the last term formula, Tn, is going to be equal to A plus N minus 1 times D. And then we can also calculate the sum. If the last term is known, we use Sn. S subscript n is equal to n over 2 plus A plus L times A plus L. The first term plus the last term times n over 2. Sir, what are you talking about? Don't worry about it. I'm just going through the definition. We will get back to this. Or if we don't know the last term, we're going to use Sn is equal to n over 2 times 2A plus n minus 1 times D. So, truth is, you will need to know these two formulas. Sometimes they will give you the progression or the sequence or the series in there's a common difference and the first term, or they may just give you the first term and the last term. So if you have a common difference, this is a formula they use to calculate the sum. If you have the first term and last term, this is a formula used to calculate the sum. So we're going to go through all of those. All right, so that's just the definition. Just wanted to define some terms there for you. So let us look at an example. If I gave you 2, 4, 6, 8, 10, and you evaluate the sum of the first 5 terms. So how you know it's 5? See here? 1, 2, 3, 4, 5. 2 plus 4 is 6, plus 6 is 12, plus 8 is 20, plus 10 is 30. So the sum of the first 5 terms is going to be equal to 30. Then, sir, is it 1, 2, 3 something that's sir? No, I agree with you. Except that the questions will not come as straightforward as this. Not that the questions are not going to be solvable, you know, but it's going to require a little bit more. Let's go. I want to develop this a little further. So I'm going to call, remember I told you that my first term is denoted A, and that my D is known as a common difference. What I'm going to do is to call my first term A, and then my second term is going to be A plus D. Then I'm adding one more D, so I'm going to have A plus 2D, adding one more D, A plus 3D, adding one more D, A plus 4D, then A plus 5D, and then I'll go all the way down until A plus N minus 1 times D. Let's just go. Look at what is happening here. My first term, 0D. My second term, I have 1D. My third term, I have 2Ds. My fourth term, I have 3Ds. My fifth term, I have 4Ds. What is happening is I'm going to have one less D than the number of terms. So this is my fifth term. So I'm going to have 5 minus 1 is going to be equal to 4D. And this is the formula. So this is how we get the last term formula as A plus N minus 1 times D. Let me show you before this thing will move. See here, A plus N minus 1 times D. And it's referring to the last term. So that is going to be the last term of the formula. All right. Do me a favor. Take 2 minutes to read through this and look at this developing story right here. 2 minutes to do through this and look at it. Yes, please.
I'll go back over developing part, please.
Okay. So I'm calling this my first term. You know? Oh, 1 minute, please. 1 minute, 1 minute, 1 minute. Mm-hmm. I just put a little space between them. Kind of look way too close. All right, let me just separate this. Okay. So what I'm saying to you here, Matthew, is this is my first term. Let me go a little closer. Thank you for your question, and I keep saying to you, ask me a question. Questions will help me to help you. No, that's not what I want. Undo, and that I want. I'm trying to find something that I can denote it to show you what it is. No, that one either. Oh. No, man. It wasn't it that is I normally use? All right. Based on your question, Matthew, I wanted to All right, let me just try something here. I want you to, okay, says it is me doing something wrong. All right. Okay, I'm correct. I'm good now. Second. All right, but in the interest of time, since I took so much time trying to find what I'm looking for, I'm just going to leave these. I'm just going to go up to the third one. This is second. That's the first. All right, watch this now. Oh Lord, it went on the other page. All right, well, sit here, and I have it there also. All right, never mind. So look at what I'm talking about here now. So I'm saying that this is my first term. A is my first term. My second term is going to be denoted by A plus D. My third term is being denoted by A plus 2D. Of course, you know that this will be my fourth term. This will be my fifth term. So I'm saying to you, if this is my third term, you recognize I have one less D. And if this is my second term, I have one less D. See it here? So that means that these are my terms, and N is representing the number of terms. So when I speak about my first term, it means that N is 1. So look here, 1 minus 1 is 0, and 0 times D is 0. So that's why I just have A for my first term. If the second term, it means that N is 2. Second term means that N is 2. 2 minus 1 is 1, so 1 times D is D. So I just have one of the D's. So I'm using this to show you that the last term formula, the general formula, is given by A plus N minus 1 times D. See it now, Matthew?
Yes, sir.
All right, cool. How does A plus N minus 1 times D relate to an AP? How does that relate to an AP? Which is what I was developing just now for you here. So I'm saying to you that my first term, my second term, my third term, this is my fourth term, this one here is a fifth term, and if you look at it, the sixth term you have 1 less D, fifth term you have 1 less D, third term you have 1 less D. So I'm saying that my last term, the general form of the equation here is going to be A plus N minus 1 times D. So this is a formula that we're going to be using to calculate the last term. So if I say to you, for argument's sake, that this here has 5 terms. The first term is 2 and the common difference is 2. Calculate the last term. I can use that formula to calculate that this last term here is going to be 10. All right, let's go. How to determine the D? How to determine the common difference? D. All right, so D is a common difference. How to determine the common difference? Look at what is happening. I'm taking one term and I'm going to be subtracting it from the term that comes before it, or the previous term. So in this example, I'm taking this term, the second term, and I'm subtracting the first term from it. So if this is going to be A plus D minus A, I'm going to get D. I'm taking away this sixth term, A plus 5D, from the A plus 4D, and I'm going to get D. All right, I'm going to get D. I'm going to get D. So if you look back at the original question, in order for me to find a common difference, I'm taking any term and subtracting from the term before it. So let us take the 10. When we subtract 8 from the 10, what do we get? We get 2. So 2 is going to be the common difference. When we have 8 and we subtract 6, we end up getting 2 again. 6 minus 4, end up getting 2. 4 minus 2, we end up getting 2. I can't use the first term because I don't have another term in front of it to subtract in order to get that. So I'm saying to you, in order to calculate the common difference, you're going to take one term and subtract it from the previous term. What do you mean, sir? The term will come before it. All right. So if you look back at the ORIGIN, the original question, you will see that the common difference there is going to be 2. All right. So I'm only making reference to the question that we're doing. And I showed you how we calculate the common difference just now. So what is the difference between a series and a sequence? So I can give you this here, 2, 4, 6, 8, 10, and I can give you 2 plus 4 plus 6 plus 8 plus 10. One is a sequence, one is a series, all right? And that's the difference. The series have the addition sign and the sequence is separated by commas, all right? So now, are you following what I'm doing so far?
Yes, sir.
Okay. So now, let us go back to our definition. So we know what is the first term. We know how to calculate the common difference. We know what the last term is. And we also know the number of terms. And we know we're going to be using all of these, A, D, L, N. A, D, this is our L, and this is our N, to calculate the last term. Of the 4 things, we need any combination of 3 to calculate the 4th one. Of the 4 things, we need any combination of 3 in order to calculate the 4th one. And the final thing for us to do is to calculate the sum of the progression. But before I do that, I need to have a conversation with you. Sir, I will ask you a question. I want to turn a businessman. And I told them, tell me, I feel integrated maths, now detail, sir. How this ever help me when we leave school? Thank you for answering me that question. I have been waiting for somebody to ask me, and I can't wait around, so I just have to ask myself. You know how this can become useful? As a matter of fact, some years ago, I was teaching AdMath, and I asked, and some students did their SBA on arithmetic progression. Their SBA on arithmetic progression. Let me see if I can. No. I'm trying to find something to show you. All right. This one here, let me just new share and show you something. So this one here, this student did using geometry progression to investigate the predictability of the average person's future flow cell phone bill. All right. Now, the truth is, these are progressions. So what the student says, you know, sir, I can use geometry progression to investigate the predictability of a person's telephone bill over a period of time. So what the student did was to generate, it says the total amount of flow cell phone bill was calculated after each year using the formula, and they have the formula for the arithmetic progression, for the geometry progression that she used. And what the student did pretty much is, in essence, what the student did was to say, in the first year, this is what I'm going to calculate my phone bill is going to be. Because what the telecommunication companies are doing now, they are giving people plans on their cell phone. Okay, fine, you get X amount of data, and it happens to you guys too. What they'll say to you is, you pay us $1,000, and we give you 1 gigabyte or 2 gigabytes of data for the month. I may say, yeah, man, that easy 1, 2, 3, that man. But you recognize now that every time I go on Zoom, it eats up the data a whole lot. So sometimes I hear some students who say to me, sir, I put on service from my phone, and I say, but in a week, the service just done, right? And so we can't put on no more service until the following month. So I don't have no data, sir. So that's exactly how it is that you cannot predict your bill. Because you're on a plan, how the system set up is that when you would have expended your plan, you can't go back and say, okay, I want another plan within the month. It don't work like that. You get a plan per month. So you have a fixed telephone bill. And I am doing a 5-year budget. I'm doing a 5-year budget because I'm in the manufacturing business and I'm making motor cars. And I want to predict what my budget is going to be like over the next 5 years because I'm doing some strategic plans. Based on the fact that I know what my phone bill is going to be in year 1, year 2, year 3, support, and so on, I can go ahead and predict what my phone is going to be. I can go ahead and predict what the water is going to be and what the electricity is going to be, support, and so on. So when I do my projections, I can take out my overhead cost versus what it is that I would have taken in as revenue. Then I can find my profit. So I can say this is a profit that is made. And that's how the banks do it. That's how NCB does it. That's how BNS does it. They have to pay over a hefty electricity bill. So when they look at all of that and they pay out their debts and they pay their salaries and they don't have anything else owing, then they can say we made $1 billion profit within the first quarter of the year. When I heard that particular news came out some years ago, that one of the major banks in Jamaica earned $1 billion in the first quarter, I had to go back and ask how many months in a quarter. And then I was reminded that it's 3 months. And in 3 months, one bank is making $1 billion. $1 billion. And guess what? The people them in the bank were complaining and said that is low. We were expecting more than $1 billion, right? But things, rate and support and so on. So you could actually predict what is happening. And what the student did was to write down in 2011, the student says, this is going to be $1,500 that we're paying. This is going to be the interest. This is the amount. In year 2, it's going to be this, and it's going up cumulatively. So at the end of 2020, over a 10-year period, she expects the bill to be cumulatively at $19,771.20. And what it is that, and you can see the gradual increase in the stuff. So what it is that she did was to use geometric progression to do the stuff. And you'll find out that what they do a lot in corporate is to incorporate quite a bit of what it is that we are doing in mathematics in order to inform them as to some of the strategic movements that they must take. All right. So it is important what it is that you're studying. Trust me, information gained will never be lost. You may just have to go back and dust it off and then use it. All right. So let's continue. So now, we want to determine the sum, and we're going to be using this formula. We're using this formula. So what is that formula again? See it up here. that formula is a formula if we know the first term and the last term. We know what the first term is. The first term is A, and the last term is 10. And we know that it has 5 terms. Remember, n is the number of terms. We have 5 terms. 2, then a 4, then a 6, then a 8, then a 10. So we know that the number of terms in this particular progression is 5. We know that the first term is 2. So how you know? Because we're starting off with 2. Okay. And then the last term is, sir, last term, but that not go up to infinity. The last term, when the people them stop. Them tell us it contains 5 terms. Anyway, them stop, that is the last term. All right? Okay, sir. So that means A is 2. I remember that. N is going to be 5. L is going to be 10, sir. And the common difference we calculated, the common difference to be 2. Yes, sir, it's true, it's 2, because 10 minus 8 is 2. Let us substitute into the formula. So this says Sn, S subscript n is equal to n over 2 times A plus L. The first term plus the last term. N over 2 times the first term plus the last term. Now, what's the first term? 2. What's the last term? 10. What is 2 plus 10? 12. The number of terms, 5. So it's 5 over 2 times 12. This 2 cancels into this 12 6 times. And 6 times 5 is 30. Or 12 times 5 is 60 divided by 2 is 30. So the sum of the first 5 terms, this is what it is saying. S subscript 5 is saying that the sum of the first 5 terms is equal to 30. But we don't know that long time. Our maths taught long time enough. So I would say 2 plus 4 plus 6 plus 8 plus 10, we get 30. All right? We didn't maths it out long time. But the man them say the plan. The man fees a formulation system to get the 30. Here the formulation system is now. N over 2 times A plus L. N over 2 times A plus L. And we get our last term there to be 30. So alternatively, it says, given the same question that we started off with, evaluate the sum of the first 5 terms. Now, using this formula, because the last term is not given, so we don't know, we are assuming that we don't know the last term. We are assuming that we don't know the last term. So you're assuming that the last term is unknown. So assume that the last term is unknown. So you're going to use this formula.
Sir.
Yes, please.
Does that formula ever mess me up?
Is this formula ever mess me up?
No, me at that when me used to do it.
It ever mess you up?
Yeah.
Oh no, man.
I multiply some of them different, I get different answer.
Yeah, if you multiply them differently, you're gonna get different answer for true. Right? But you're gonna get it this time, man. No, mess up again. All right. So we're gonna assume that this part here, I'm assuming that the last term is unknown. So when I assume that, so this is what I'm saying now. Using the formula because the last term is not known. So how you know that? We're assuming. Yeah, take time till it, so we're assuming, so we don't know the last term. So you mean that, you know, so the last term up here, so shh. We don't know so the last term. All right. So now, so all we have is just the first term 2. We know that it contains 5 terms, and we know that the common difference is 5. So we know L is 10. No, we don't know it. We don't know that yet. All right. All right. So let's go. So we have S subscript n is going to be equal to n over 2 times 2a plus n minus 1 times d. This is a formula we're going to be using. 2a plus n minus 1 times d. Watch me. Watch teacher. N is 5. Put in a 5 right here, so over 2. 2 times a. But a are 2, so I put in a 2 right here, so. Plus n minus 1. But sorry, say n are 5. Yeah, man. So it'll be 5 minus 1. And d is 2. See it right here, so we're going to put the 2 right here, so. And then no. Look how we're going to do. 2 times 2 is 4. See it right here, so. 5 minus 1 of 4, see right there so. And we care about the 2 right there so. And then 2 times 4 is 8. And 8 plus 4 are 12. We can answer 4 plus 4 are 8 first, and then times it by 2, you know. That says multiplication and division before addition and subtraction. So we have to say 4 times 2 is 8. And then 8 plus 4 is 12. And that's so communicate our S5 to be equals to 30. The sum of the first 5 terms to be equals to 30. Any questions?
Sir, why never multiply the 2 by the 12 instead of by the 5?
No, because this 2 is in the denominator. That 2 is in the denominator, and the 12 is actually 12 over 1.
Oh, okay, thank you.
Yeah, man. I'm going to do something before here. Before I give you this alternative, I'm gonna develop something else. I'm gonna develop something else. I'm gonna develop something else. I'm going to tell you why I'm developing something else. What I just did a while ago was to use a formula that I don't show you how I get. This one here, I show you how I got these. And I show you about this one. But this one here now, I need to show you first how I develop it. So let me just develop that one and show you something here. So developing. I want you to take a close look at the sum. S subscript n is equal to n over 2 a plus l. I want you to look at that. And I also want you to look at the last term formula to be equals to a plus n minus 1 times d. Now, if they ask me to calculate the sum, and I know that the sum formula is going to be n over 2 times a plus l, but I don't know what l is, I'll have to go and use this formula in order to calculate l. I'll have to use this formula in order to calculate l and then substitute it right here so I can get my stuff. But the man them say here the plan. Instead of going through all of that, we're going to just get a formula, a separate formula, so that we can use it if you don't have the last term. So what the man them do is to say, all right, you see that L here? You're going to take all of the L here and put it in and substitute it for this L. Remember, this L is a plus n minus 1 times d. So we're going to substitute the L into the formula. So watch this now. This is this n over 2 is right here. So this a is right here. So you see this is all of this L that comes, oopsie daisy, it's all of this L that comes right in here. So a plus n minus 1 times d, see here? A plus n minus 1 times d. So all of this is my L that I'm substituting. All right? So when I substitute that L in there now, I can say, okay, if I remove the parentheses, I'm going to have a plus n minus 1 times d. See here? A plus a times n minus 1 times d. But a plus a is not a squared. A plus a is 2a. So that's what I'm going to end up with now. S subscript n to be n over 2, 2a plus n minus 1 times d. And this would be the preferred formula for evaluating some of the terms in an AP, and especially when the common difference, where the last term is not known. When the last term is unknown. All right? So when the last term is known, we use S subscript n is equal to n over 2a plus l, the first term plus the last term. When the last term is unknown, we are going to be using a plus 2a, sorry, n over 2 times 2a plus n minus 1 times d. All right, so if you look at the formulation, there are really 3 different formulas for AP. One, L is equal to A plus N minus 1 times D. L is equal to A plus N minus 1 times D, the last term formula. And after the last term formula, then we can have the sum formula. The sum formula says S subscript N is going to be equal to N over 2 times A plus L, right here so. A plus L, right here so. And then, if we don't know the last term, what we did was to combine the last term formula with the sum formula to give us another sum formula, which works out to be this one here. Which works out to be this one. So that's what I was saying to you just now when I did the question. All I did was just to copy the thing at the bottom and just put it up top. That's exactly what we did. We don't have the last term. See here? Assume that the last term is unknown. We don't know the last term, so we're going to end up now using the formula that says we don't know the last term. And when we substitute it, we still end up getting our S5, S subscript 5 to be equal to 30. So what is S subscript 5? S subscript 5 is saying to you that it's going to be the sum of the first 5 terms of the progression. S subscript 5 is saying to you that it is the sum of the first 5 terms of the progression. Question? All right.
Sir?
Go ahead.
Sir, for the N over 2, is the 2 what's B equal to, or is it just like always supposed to be there?
All right, so the 2 is always going to be there. You notice in the formula here, the last term formula and the formula that with the last term and the one without the last term, you still have N over 2. You still have this N over 2 here, and you still have this N over 2 here. So this 2 is constant. This N over 2 is going to be a constant variable. N over 2 is going to be a constant variable in order to evaluate it. All right, so there's a question that was sent to me. Sir, do you have to prove your answer when you finish? No. You're going to be so confident that this is it and I don't have to prove a thing. You don't need to prove it. You don't need to prove it. I guarantee you. All right. I have been talking a lot. I have been talking a lot. And I want to see how many of you can transfer the knowledge that you just got. I have a follow-up question stemming from the one that we just did a while ago. Stemming from that one we just did a while ago. I want you now, given 2, 4, 6, 8, I want you to evaluate the sum of the first 20 terms for me. Evaluate the sum of the first 20 terms for me. And I'm giving you 3 minutes to do that. See the working out up here, so? Use 3 minutes and start working on that for me, please. Why when I'm mute and given a work to do, it's just dead silence. No little clearing of the throat or
Finish,
nothing.
sir.
Channel star. All right, thank you. What you got for the answer?
Sir, I got S20 equals 420.
420. That's not correct. Anybody else got that?
Yes,
I got
sir.
220.
That's not correct.
Sir, 210.
220, sir.
Congratulations. Pulling your legs. Very nice. Very,
Sir,
very.
seriously.
Guess what? Tan, talk truth. A while ago, you sweat little a while ago, don't it?
Yes, sir.
Me know. When sir say that's not correct, you're like, you're wrong.
So, sir, sir, the A and the B is always
No, sir, but if you get
Okay.
it wrong, you not teach right.
Kimoli, go away. Go away, Kimoli. It's your bedtime. Go ahead, Kimoli. You're saying honestly something.
So I was asking if the A and the B is always equal to 2.
No. You see, John Mark, you see this question? I'm overkilling this question. You see, all the questions we've done so far is relating to that one first question. And the reason why I hold on to that one question there, because I want to work it. When I'm moving to other questions, I'm going to say A has a different value. A can be a whole number. A can be a fraction. A can be a negative value. D can be a fraction. D can be negative. Yeah, man. Talk truth. This question is an overkill. If you look at it, 2, 4, 6. See it here, so 2, 4, you see it? Are the same question we are work. Same question, but I'm overkilling it. All right? Kimoli, you're saying something, honey bunches. Go ahead.
Oh, sir, I was just saying if you get it wrong, then you just not teach right.
All right. And you win. You're right. You're correct. Okay. Now, hear what is happening now. John Mark, Stewie, you asked a question a while ago. Sir, A and D will always be 2. See one next question now. You work it and you tell me if, matter of fact, what's the value of A? What's the value of A?
And 110 answer?
No, look at the question. Duh. The value of A has to be 1. Thank you, Shantifu. The value of A has to be, A is the first term. What's the value of A? A is the first term. A is 1. What's the common difference? What's the common? How you get 2, John Mark?
I just subtract 3 from 1 from 3.
No. Yeah. Subtracting 1 from 3. You're correct. Yeah. 1 from 3, you get 2. And 7 from 9, you get 2. And 5 from 7, you get 2. So you're correct. Now, let me just tell you something. The common difference, when you subtract all these numbers, you're supposed to get the same number. And that's why it's called a common difference. That's why it's called a common difference. All right. So you know the first term, I know the common difference. Work the question for me, please. And you win. I'm coming back to you, John Mark, when you finish this.
What was the common difference?
Common difference? The common difference is 2. 3 minus 1, 2. 5 minus 3 are 2. 7 minus 5 are 2.
Finish, sir.
What's your answer?
240.
So 225 in Kenya.
Sorry, me get 225.
That me wanted to
225.
We better go check 1 + 1 again until we get check at 2 minutes. No, 2 seconds rather.
Sir, will them give the answer already, sir?
Yeah, them said 525. Where you get?
No, sir, wait there. Correct?
Huh?
You correct?
Them sound right. Where you get? Tell me where you get first.
16.
16?
16. Wait there, sir. Almost see.
Okay, sir, I got it.
What you got?
225.
Okay. Very nice. Very nice. Now, some of you, your silence is deafening. Deafening. And there are others in the class, yes, who are always speaking up, but they don't always get the correct answer. And I send them back to the drawing board and they work and they get the stuff. Some of you, Jesus, Father, it no matter how I try to create an environment for you to feel comfortable to talk, on a not talk, on a mouth shut tight. And I know better. I know better. Teaching longer than some of you born upon this earth. I know better. I know better. I don't know what else to do. I don't know what else to do. I know the ones in the class that are understanding now. Go ahead, please.
So the difference in term is 2. Can I
Yeah.
see the question again, please, sir?
Yeah, man. Sure, no problem. The difference is going to be 2. Let me just do this so you can. Oh, come on, Mr. Shan. That's not what you're supposed to be doing. What is wrong? I get nervous. All right, there you go. Difference is 2.
Sir, what's the name of this topic again?
Arithmetic progression. You like it?
Thank you. Yeah,
It nice, man. It nice. Me not lie you. It nice. It nice.
Some of the terms, some of them, you know, that's why whenever I get the right answer.
I'm going to take your lunch money for tomorrow that I want to do. And then I go buy some nice lobster and rice for my lunch. But I'm happy that you're seeing where it is that you're going wrong. And that's important. Let me tell you what is important, guys. When you're doing math is one of those unique subjects. I mean, but that's why I love it so much. That it is so sequential. That if you don't follow the sequence, you are going to get in trouble. And I'm saying to you, if you notice how I teach, you notice I keep saying to you, the question at the start looks very long and arduous. You know why? Because I dissect it and treat the question in such a way that I look at all the possible questions that you could ask me about this particular question. And then I deal with those questions and those issues so that when you get the questions on your own, all of those things come out already. All right. So it's very good. Are there any questions relating to my number 2, the 13579? There's a point I want to bring across in the. I come in, Tarek. Don't hang up, Tarek. I come in. There's a point I want to bring across, but I'm not going to talk about it yet until I do GP. When I do GP, I come back to that. Go ahead, Tarek.
So I was just saying there is no question.
Okay, no question. Thank you, Poppy. All right. Okay, so I can't give you that one yet because I don't reach that. I don't do that part here with you yet. I don't want to do that with you yet. All right. I don't want to do that. Rockstone, so I keep class done. All right. Sorry about that, guys. I overstayed my welcome. All right. And look for me bright now. It's a good thing. Said the Father God tell me, say, no, don't do that one yet. And I look down on the clock and see it's 8:35. See? Class all done and they don't even recognize, or they recognize and send an answer me. Anyhow. Thank you.
Send this now.
I'm gonna send it now, Natibu. Thank you for coming out as per usual, you guys. I kind of upset with a little one or two of you because they're not talking to me still. But for the most part, I am pleased with the class. So keep up the good work, continue working very hard. I'm just going to take a little break and then I fix up the notes and then I send it off to you. All right? Be shy. Let's not think about the shy. All right. All the best here, guys.
Bye, sir. Same to you.
Bye,
All right.
sir.
Take care.
Bye, sir.
Yeah, man.
Bye, sir.
Cool.
So, sir.
Yeah. I'm here.
Sir, you're going to send the
If I'm going to send the stuff for you, all right. Kim, do me a favor, Kim. Link me tomorrow about tomorrow. Is that time? Tomorrow's Tuesday. Oh Jesus, do we have meeting tomorrow? Link me about 11 o'clock tomorrow. Yeah? By the way, what time are you available tomorrow? Huh?
Sir, between 2 and 3.
You're available between 2 and 3?
Yes, sir.
All right. Link me at 1:30 just to send me a message 1:30 to remind me that you're available at 2 so we can talk at 2.
Okay, sir.
All right, cool.